What's up, everybody? So one of the things that we forgot to pre-wire was this Renogy remote. It is kind of massive for what it's worth, so we're going to talk about kind of the way that this thing works, and then we're going to replace it with its own little button switch. So stay tuned. So as mentioned, we totally forgot to pre-wire our remote control for our inverter. So we got a Renogy inverter. It came with this remote control. The part number is RMS-P2, but as you can see, this thing is freakishly large, right? It seems way bigger and really light for probably all of the functions that it needs. So our plan is to wire it to this push button here. So I did take apart this unit here, and it's pretty simple how it works. So there's 4 screws on the back. Just remove those to take this back plate off. Then there's 4 more screws that hold the PCB to the faceplate, and then it's also soldered into the button with these 2 leads here. So at this point I've unscrewed all those screws and then desoldered these 2 leads. But as you can see, it's basically just this RJ11 connector, the male side or female side, which plugs in your RJ12 cable into there. But then it's got a couple of surface mount resistors that lead to the LEDs, as well as a capacitor on the, I think that's the red LED there. So there's a lot of volume here that it actually needs. So what I've found online was basically this SPDT button switch that has addressable LEDs. So I actually disassembled this thinking I would need to break a couple traces for the circuit board, because I thought that the lights are kind of attached directly to the switch positions. So it was marketed as like when you push the button, this light turns on. When it's not on, this other button or this other light turns on. But luckily these are addressable themselves, so they actually have their own pins to power on the light whenever you need it to be on. So our plan is to basically get rid of this whole assembly for the remote control and just replace it with this little switch. So I do have the pin out here. I did basically take my multimeter and kind of trace out where each pin goes in terms of, like, you know, pin 1's ground, pin 2 goes to the red LED, pin 3 goes to the switch, whatever. So we could leave that pin out in the description, but basically 1 and 6 are ground, 2 goes to the red LED, that's the power for it, 3 is your switch out, 4 is your switch in, the green LED is switch 5, and then, yeah, like I mentioned, pin 6 is ground again. So here is kind of my diagram for how I'm going to be connecting these. I'm basically going to just chop this off and solder it to these connectors, or at least I'll solder it to these wires that ultimately plug in to the switch itself. So I think in general this makes a lot of sense. I mean, why would you have this whole thing if you could just have this, right? And it still keeps all of the functions, all of that. And just for good measure, I did completely remove this just for the sake of seeing if there's any other traces that I didn't see from one side. But if you hold this up to the light, you could see that the traces, there's no more traces than what you can actually see here. So sometimes there are like 3-dimensional traces where there are layers and layers of them, but this is just a single layer with a few chips on it. And so, yeah, one other thing to mention too is that these resistors are probably just to limit the resistance or limit the current going to the LEDs. But as far as this switch goes, all of the LEDs are prepared for 12 volts. And then that capacitor is, you know, not really important, so that's not something that we actually need to reproduce on the switch. There's probably just some light, I don't know, probably just smooths out the noise or any sort of light jitter or whatnot. That isn't really going to be a problem in the first place. So we're going to cut this off get it soldered to our connector, and go from there. Alright, I got it all soldered up. Just going to give it a quick continuity test, just to make sure everything's still good and kosher, and then we should be set. So I'm just going to use the PCB as my, I don't know, breakout, I guess, just so I could access the pins. Otherwise it would be kind of hard to try to get my little lead in there. And so we could just go down the line. So this first pin, let's see if I can get this cable to cooperate. Okay, we'll just go from underneath it. So pin 1 on the board should equal green, or the ground, which I believe is this one. So if I hold this there we go. On the board, pin 2 is black, which should go to red. So pin 2 to red, which is this guy. There we go. Pin 3 is yellow on here. It's hard to get a good contact. There we go. Pin 4 is blue, which I think is this one. There we go. And then pin 5 goes to green, which is this guy down here. There we go. Nice. So, looks like we're all set. And now, effectively, we could just use the switch. So, I'll just need to feed this through, and now we have got a way smaller footprint with all the same functions, hopefully. I don't have a really good way to test, whether or not these LEDs will light up with the error codes. Well, at least for the on, we could test when we get the unit installed, but at least for the error light, which is the red, even if it doesn't light up when the thing is erroring, we'll know it's erroring because obviously the power is not working to something, probably. So we'll call that good. So yeah, now we know how this works. Alright, and with that, all of our wires are looking good. They're all soldered up and ready to go, so now we can pre-wire that in. But in short, we replaced this ginormous Renogy RMS-P2 inverter remote control with just this little tiny button switch. So if you want to find this switch, we'll leave a link in the description. But in general, all you need to know is that you're looking for an on-off switch that has addressable LEDs. So it's not actually going to say addressable. You just want to look for extra pins that relate to the power of the LEDs itself. So yeah, I hope you enjoyed this video. It's a short one this time, so just good. But if you want to see any of our other struggles, feel free to take a look at our channel. Otherwise, we'll see you on the next one. Peace.